Mathematics students from countries as far-flung as Australia, Belize, and Hong Kong may have everyday contact with decagons, since those countries have used the 10-sided shape in their coins. Decagons are polygons. Decagons belong to the family of two-dimensional shapes called polygons. Polygons get their name from Greek, meaning many-angled. Because all polygons have multiple interior angles, they close in a two-dimensional space using only straight sides. A decagon is a 10-sided polygon with 10 interior angles and 10 vertices, which is where the sides meet. For a polygon to be a decagon, it must have these identifying properties: 10 sides, 10 interior angles, 10 vertices. In many decagons, the sum of interior angles will be 1,440 degrees. But that is not an identifying property because complex decagons will not have that sum. Regular decagons have two additional identifying properties: 10 exterior angles of 36 degrees and 10 interior angles of 144 degrees, summing to 1,440 degrees. Drawing a decagon takes no skill. Simply draw 10 line segments that connect and you have it. Drawing a regular convex decagon, however, takes real skill, since each interior angle must be 144 degrees and all sides must be equal in length. Drawing a concave decagon is actually fairly easy. Make a 5-pointed star and fill it in. That is the star that appears 50 times on our country's flag, and the outline of such a pentagram is a decagon. Be careful to know the difference between the 5-pointed pentagram, the lines cross themselves, and the decagon, either just the outline of a pentagram or a solidly filled pentagram. Let's look at the different types of decagons. All polygons can be drawn as regular, equal length sides, equal measure interior angles, or irregular, not restricted to congruent angles or sides. The regular convex decagon is a subtle and elegant shape, with 10 exterior angles of 36 degrees, 10 interior angles of 144 degrees, and 10 vertices. Because it is a challenging shape to make, the regular convex decagon is popular with coins, like those from Australia, Belize, and Hong Kong. Irregular decagons must simply have 10 sides closing in a space, but the lengths of their sides can vary greatly. Most polygons can be convex or concave. Convex decagons bulge outward, with no interior angle greater than 180 degrees. Concave decagons have indentations, creating interior angles greater than 180 degrees. That is why the outline of a 5-pointed star is a concave decagon. It has 5 interior angles, each of which is far greater than 180 degrees. So far, all the decagons discussed, regular, irregular, concave, and convex, share the same properties: 10 sides, 10 vertices, 10 interior angles. They also share one more property. Their interior angles always add to 1,440 degrees. That is not the case with complex decagons. Decagons can be simple or complex. A simple decagon has no sides crossing themselves. A simple decagon follows all the conventional rules of polygons. By contrast, a complex decagon is self-intersecting. In crossing its own sides, a complex decagon sets off additional interior spaces, but it is still said to have only 10 sides, 10 interior angles, and 10 vertices. Because it is so highly irregular and self-intersecting, a complex decagon need not follow any predictable rule about interior angles or their sums. Notice that a single decagon can fit into several categories. The classic regular decagon meets all these requirements: regular decagon, convex decagon, simple decagon. So to be absolutely accurate, and maybe a bit fussy, you could describe this figure as a regular, convex, simple decagon. Let's look at several decagons. See without looking at the identifying information if you can determine whether each is regular or irregular, convex or concave, simple or complex. Remember to name all the attributes, in case a shape fits more than one category. In order, those decagons are a regular convex simple decagon, a concave simple decagon, a complex decagon, a concave simple decagon.